Hello, this is Miss Heaney. This is the last lesson of this unit. So if you have not completed the previous lessons and the previous classwork, I would go back and do that first, especially the previous two lessons. That would be the one on solving absolute value equations. That'll definitely be some stuff you will have needed to seen before doing this lesson. It also includes solving inequalities. So those two lessons, lessons 3 and 4, make sure you've done those before doing this one. All right, so if you're ready to do this one, meet me on page 110. This is the top of page 110. These first few problems are just a review of solving absolute value equations. Remember that absolute value means the distance between that number and 0 on a number line. So there are two different numbers that have a distance of 9 from 0 on a number line. That would be positive 9 and negative 9. So that tells me that whatever is inside this absolute value, whatever r minus 7 is, could be two different possibilities. Either r minus 7 could be positive 9 or negative 9. And so this is where we split this into two different equations. We have two possibilities here. R minus 7 is 9, or r minus 7 is negative 9. And those are two equations that I can solve to find my two answers. If I solve these equations, I would want to add 7 to both sides, and I get an answer of r equals 16. Oops, running out of room. On the other equation, I'm also going to add 7 to both sides to isolate the variable, get r by itself. I get r equals, on the right-hand side of the equal sign, I have negative 9 plus 7, which is negative 2. So I have these two different solutions, 16 and negative 2. They're both correct, and they are both solutions to our original equation. Number 2 is a little bit different. We are going to be splitting this into two different equations, but first, I want to know what the absolute value is equal to. In order to figure that out, I need to get that absolute value of t plus 9 by itself first. So I'm going to get rid of the stuff around the absolute value. I'm going to get rid of this 4. I'm going to get rid of this minus 5. The first one I want to deal with is the minus 5. I'll do that by adding 5 to each side. Once I've added 5 to each side of the equal sign, I end up with 4 times absolute value of t plus 9 equals 19 plus 5 is 24. The absolute value is not completely by itself yet. In order to do that, I need to divide both sides by 4. Since my absolute value is being multiplied by 4 currently, and those will cancel, I'll divide the other side of the equal sign by 4 as well, and I get the following. Absolute value of t plus 9 is 24 minus, divided by 4 is 6. And I'm going to skip example 3. I don't have room for that. Okay, absolute value of t plus 9 equals 6. Now that I have the absolute value part by itself, I know that whatever is inside this absolute value is a distance of 6 from 0 on the number line. So that's two possibilities. That's either positive 6 or negative 6. And I'm actually going to split this because I'm running out of room, like so. So I have these two possible equations. Either t plus 9 is equal to positive 6, or t plus 9 is equal to negative 6. They're both possible answers here. I'm going to solve each of these two separate equations. So t plus 9 equals 6. I could subtract 9 from both sides to get t by itself. I get t equals negative 3. So there is one possible solution. On the other equation, I'm also going to subtract 9 to get t by itself. So I get t by itself on the left-hand side of the equal sign. negative 6 and negative 9 combine to negative 15. So I have these two possible solutions. T is equal to negative 3 or t is equal to negative 15. They are both solutions to the original equation. All right, so just some reminders here. Recall that the absolute value of some number equals 3 means that the distance between that number and 0 is 3. That has some implications for inequalities. The inequality of some number, absolute value of some number is less than 3 means that the distance between that number and 0 is less than 3. That is the graph that is shown right here. If the distance between that number and 0 is less than 3, then the distance could be a distance of 1. So it could be one space to the right of 0 or to the left of 0. It could also be a distance of 2, so 2 spaces to the right of 0 or 2 spaces to the left of 0. It could go all the way up almost to 3, like 2.9 is almost 3. So I could go a distance of 2.9 to the right of 0, almost to 3. I could go a distance of 2.9 to the left of 0, almost to 3. I cannot go a distance of 3 or more. So 3 is out, 4 is out, 5 is out. I can't go far enough to get to those numbers. I also can't go far enough to get to negative 3, negative 4, negative 5, or anything to the left of that. So anything in between negative 3 and positive 3 is fit by this description. What if I switch around the inequality symbol? The inequality absolute value of some number is greater than 3 means that the distance between that number and 0 is greater than 3. So I'm looking for distances greater than 3, more than 3. So I could go a distance of 4. If I go 4 spaces to the right of 0, that's okay. If I go 4 spaces to the left of 0, that's okay too. I could also go 5 spaces to the right or to the left. I could go 6 spaces to the right or to the left, or 7 to the right or to the left. What I can't do is go any distance that is 3 or less. I cannot go 2 to the right or 2 to the left. That would be too short of a distance. I can't go 1 to the right or 1 to the left. That would be too short of a distance. I also can't go 3 to the left or 3 to the right or 3 to the left. That would be too short. It has to be more than 3. So this graph shows that possibility. So everything to the left of negative 3 and everything to the right of positive 3. It's kind of the exact opposite of the graph before. All right, so this will help us with solving a few examples here. Example 1, solve and graph. The absolute value of x is less than 2. Remember, that means that the distance between whatever x is and 0 is going to be less than 2. So I'm going to go to my number line here. I'm going to set up a number line. I want to make sure that 2 and negative 2 are part of my number line. I also want 0 to be part of my number line. So I'm going to start at negative 3, negative 2, negative 1, 0, positive 1, 2, and 3. So if I'm thinking of all the numbers that have a distance away from 0 of less than 2, so that could be a distance of 1. So that could be one space to the right or to the left of 0. That would be fine. I could go half, distance of 1/2 to the right of 0 or half to the left of 0. That would be fine. That's less than 2. I could go 1.5 to the right of 0. I could go 1.5 to the left of 0. That would be fine. I can go any distance that is less than 2. So I can't go 3 to the right or 3 to the left. I also can't go 2 to the right. That would be too far. So I want to show that 2 is my boundary. So I'll draw an open circle at 2. I won't fill it in because I cannot go a distance of 2. I can only go less than 2. Same thing to the left. I can only go a distance of less than 2 spaces to the left. But anything between those two numbers is fair game. I can reach anything between 2 and negative 2 as part of my answer. Remember from the last lesson that this is called a compound inequality. There are two different inequalities that are going into effect here. X could be less than 2, and x is also at the same time greater than -2. It's between those two numbers. So here's our actual solution. I could write this as x is less than 2 and x is greater than -2. Because we're describing numbers that are in between -2 and +2, remember another way that we could write that is with x in between those two numbers, so -2 is less than x is less than 2. That's another possible way that we could write our answer. Let's try example 2. This one has the, different number, 5. It also has the absolute value symbol switched around, so we're going to end up with a different looking graph than in example 1. Remember, this inequality means that the distance between x and 0 is greater than 5. So, on my number line, now this is not going to have enough room to go 5 to the right of 0 and 5 to the left of 0. So I'm actually going to scale this a little bit. I'll start with 0 in the middle, and I'm actually going to count by 5s. So 5, 10, 15, -5, -10, -15. You can always count by a certain number if you want to make sure everything fits in your number line like that. All right, so the absolute value of x is greater than 5. That means the distance between my unknown number and 0 is more than 5. So I could go a distance more than 5, like a distance of 10. I could go 10 to the right and 10 to the left. That would be perfectly fine. I could go 15 to the right and 15 to the left. I could go 20 to the right, 20 to the left, or any number more than that. I could also go 6 to the right, 6 is more than 5, or 6 to the left. I cannot actually go a distance of 5. I want my distance to be greater than 5, more than 5. So 5 would be too short. So I'm going to mark 5 with an open circle as my boundary number. That's where I'm stopping my shading. And I don't want to shade anything in between because that would not be a distance of more than 5. So it looks like everything to the right of 5 and everything to the left of 5 is going to be part of my answer. Now if I think about this compound inequality, here are the two inequalities I have here. I have everything less than or equal to -5, which I have right here, or everything greater than or equal to +5, which I have right here. So my solutions are all real numbers greater than 5 or less than -5. So we have these two types of graphs for compound inequalities. We have this first type where we're shading everything in between those two numbers, and we have the second type where we're shading everything on the outsides of the two numbers. The key thing here, key difference, is the direction of the inequality symbol. Basically, anytime you have a less than symbol, that is going to be a compound inequality where you're looking at everything in between those two barriers. Anytime you have a greater than symbol, you're looking on everything on the outside of those two barriers. All right, we're going to solve some more problems like this on the next page. On page 111, we're going to solve and graph. X is less than or equal to 3. Less than or equal. That tells me the distance is less than or equal to 3. So small numbers like 0 and 1 are okay for our distance. We don't want to distance anything more than 3. So this tells me that we're going to have a shading that's in between 3 and -3. So I'm going to first set up my number line. I want to make sure I get to +3 and -3. So if I have 0 in the middle, okay, 1, 2, 3, that works. -1, -2, -3, cool, this will fit. So if I want my distance between my unknown numbers and 0 to be less than or equal to 3, then I'm going to count everything that's between positive 3 and negative 3. Anything that's in between those is a possible answer. These all have a distance that is less than 3 away from 0. But because I have this or equal to part, I also want to include a distance of exactly 3 in my answer. So I'm going to make those closed circles. Number 2. First I'll set up my number line. I want to definitely have 0 in the middle, and I definitely want to get to positive 1 and negative 1. So I go 1, 2, 3, negative 1, negative 2, negative 3. That's perfectly fine. All right, absolute value of x is greater than or equal to 1. So that tells me that this absolute value, this distance from 0, is going to be more than 1. So I don't want anything that's a shorter distance from 0 than 1. I want any number that is farther away from 0 than 1 and farther away from 0 than negative 1. So this is one of those inequalities that goes out from the two sides. I also know that I'm including a distance of 1 in my answer, so I'm going to go ahead and shade in those circles and make them closed circles. All right, so here's an important concept here. If I have some sort of inequality that I'm actually going to solve, kind of like the inequality equation, so absolute value of some expression is less than c, this is a compound inequality where this expression is between the values of c and negative c. So I could write the inequality this way, and we'll see an example of that shortly. If I have the absolute value of some expression greater than c, that's going to be more like this situation where I'm looking at everything on either side of those two numbers. So I would split that into two different inequalities. So that expression is less than negative c, or that expression is greater than c. This probably doesn't make a whole heck of a lot of sense right now. We're going to do some examples, and hopefully that will clarify things with more concrete examples. So example 3, solve and graph the absolute value of x minus 5 is greater than or equal to 7. Okay. We have our original inequality, absolute value of x minus 5 is greater than or equal to 7. Remember how we had to split the equations into two different possibilities, a positive or negative option? We're going to have to do the same thing here. We're going to rewrite it as a compound inequality. So two different options here. Either x minus 5, whatever that is actually greater than or equal to 7. So basically the exact same inequality, just without the absolute value symbol. Or we could have negative 7. Notice that two things switch here. The sign switches on the 7, and also the inequality symbol switches around. So this one, I'm going to have to switch inequality symbol. So unlike the equations where all we had to do was switch the number on the right-hand side, we had to consider the positive and negative options. This time we actually have to switch around the inequality sign as well. All right, I'm going to solve each of these by adding 5 to each side of the inequality symbol. To cancel the minus 5, I end up with x is less than or equal to negative 7 plus 5 is negative 2. And there's part of my answer. The other part of my answer I'm going to find from solving this inequality. I'll solve this also by adding 5 to each side to cancel the minus 5. So add 5 to each side of this inequality symbol. I end up with x is greater than or equal to 7 plus 5, which is 12. So I have these two possibilities. I have x could be less than or equal to negative 2, or x could be greater than or equal to 12. That gives me a ton of numbers that will work for this original inequality. All right, we're going to write a description of the solution of the inequality. For this one, I know that my possible answers are all numbers, let's see, all real numbers, I'm going to say greater than 7 units away from 0. I'm not sure if that totally makes sense because we're not going from 0. My inequality so I'm going to skip this one for now. We might come back to it. I'm going to go straight to part C, draw the graph for the solution on the number line. I want to graph both of these on the same number line, so all the numbers less than -2, all the numbers greater than 12. Now I got to be really careful. I want to make sure that everything will fit on my number line. So I believe if I start from, I'm going to count by 2. So if I start from -4, then skip 1, -2, skip 1, that's 0, skip 1, that's 2, 4, 6, 8, 10, 12, 14, 16. Great, I have -2 and 12 fitting on my number line. Perfect. And notice that I only numbered the even numbers. That's okay. You don't necessarily have to write down every single little number on your number line, especially if you have to have a pretty wide spread of numbers like this. So this is fine. All right, so I'm going to graph both of these. I'm going to graph x is less than or equal to -2. That would be a closed circle at -2. And everything less than or equal to -2 would be shading to the left. I also have these numbers as part of my solution, all the numbers greater than or equal to +12. So I'm going to have a closed circle at +12 because of the or equal to part. 12 is part of my answer. And I'm going to shade all the numbers that are greater than 12. So that's 13, 14, 15, 16, etc. And there's my graph. All right, next example. Solve and graph. 2x minus 1 is less than 11. I have a choice here. Because this is a less than situation, I could write this as a compound inequality, which I'll show you how to show this in a minute. I could also, I'll show you another way of doing this problem as well. I could do the splitting this into 2 different inequalities option also. So I could split this into basically the same inequality but without the absolute value sign. So 2x minus 1 is less than 11. This would be fine. The other option is 2x minus 1, switch the sign, is greater than, and switch 11 to -11. So this was that extra thing we had to do. Switch the sign and switch to -11. That was the extra thing we had to do for the negative option. And I could solve each of these separately. So I would solve this by adding 1 to both sides first. I end up with 2x is less than 11 plus 1 is 12. Divide both sides by 2. And I end up with x is less than 6 as part of my answer. The other part of my answer I'll get by solving this inequality. Again, I can add 1 to both sides, plus 1, cancel. I get 2x is greater than -11 plus 1 is -10. And finally, divide both sides by 2, and I get x is greater than -5. And there's my 2 answers. Now the cool thing here is notice how I did the same work for both of these. I added 1, I added 1. I divided by 2, I divided by 2. Because we can write this as a compound inequality, Another way that I could show work for this problem is to do all the steps to this compound inequality at once. This is pretty cool. I'm going to show you this on the next page, page 112. So again, this is a perfectly fine way to show work. I know exactly what I would need to graph from this, but I'm going to show you an alternate method of showing work for this problem on page 112. So let's flip over to 112. All right, so I have this compound inequality. I have that 2x minus 1 is between negative 11 and positive 11. What I could do is, now that I have, this is not like an equation where there's two sides, there's kind of three different places. I could add 1 to all three sides of this. So I'm going to add 1 here, here, and here as one of my steps to start getting x by itself in the middle. What do I get? Negative 11 plus 1 is negative 10. 11 plus 1 is 12. And in the middle, the minus 1 plus 1 cancels. So I have negative 10 is less than 2x is less than 12. My second step, remember, was to divide by 2. So I'm going to divide by 2 to get x by itself. Divide by 2, oops, divide by 2 on this side, divide by 2 on this side. The 2's cancel. And, oops, I guess I could have shown that right here. Oh well. Negative 10 divided by 2 is negative 5. 12 divided by 2 is 6. Notice I get the same answers. My answers before were x is less than 6 and x is greater than negative 5. So this is really showing me the same thing, but because this is a greater than compound inequality, or I'm sorry, because this is a less than compound inequality, I can write this as one expression like this. You don't have to do it this way, but you can if you want. All right, I'm going to skip part B, and I'm going to skip straight to the number line. I want to make sure that 0 is part of my number line. I definitely want to make sure that I have negative 5 and positive 6 as part of my number line. So I am going to start at, let's say, I'm going to count by 2's again. I'm going to start at negative 8, negative 6, negative 4, negative 2, and 0, then 2, 4, 6, 8, 10, 12. Definitely have negative 5 and positive 6. All right, so this one, I could either write my answer this way, or I could write my answer like I did on the previous side, which, if you'll remember, was x is greater than negative 5 or x is less than 6. Either way you want to write your answer for this one is perfectly fine. They mean the same thing. If I am graphing, let's start with this one. If I'm graphing these two inequalities, okay, so I want to start with this one. X is greater than negative 5. That'll be an open circle at negative 5, and everything shaded to the right of negative 5. And I'm just going to start that shading, because you'll see what's going to happen in just a moment. When I start graphing x is less than 6, it's going to be an open circle at positive 6, and everything less than 6, so everything to the left. Now, as you can see, these two shadings are going to meet in the middle here. And that is everything in between negative 5 and positive 6, which, if you take a look at this way of writing your answer, shows the same thing. X is between negative 5 and positive 6. Let's do two more examples here. Solve and graph. All right, so this one, absolute value of 4x plus 5 is greater than or equal to 7. I'm going to split this into two possibilities. Either 4x plus 5 is greater than or equal to 7, just like the original equation had, or there's my negative option, 4x plus 5. Remember, two things have to change. The inequality switches around, and 7 becomes negative. And I'm going to solve each of these separately. I'm going to start by subtracting 5 from each side. I end up with 4x is greater than 2. I'm going to get x by itself by dividing by 4. 4 doesn't really go into 2, so I'm going to have a fraction answer, 2 over 4, which simplifies to 1/2. So part of my answer is all the numbers that are greater than 1/2. I'll get the other part of my answer from this equation. I'll do the same thing to solve this equation. I'll start by subtracting 5 from each side to cancel the plus 5. I end up with 4x is less than or equal to -7 minus 5 is -12. Then divide both sides by 4 to get x by itself. I end up with x is less than or equal to -12 divided by 4 is -3. So I also want to include all the numbers less than or equal to -3 in my answer. All right, I'm going to make a number line. I want to make sure that -3 is part of my number line, also 1/2. So I'm going to start at -4, count up to -3, -2, -1, 0, then +1, +2. All right, so I want to make sure I get both of these. I'm going to graph everything greater than 1/2. 1/2 is kind of hard to show on a number line, but I know 1/2 is between 0 and 1. So I'm just going to put an open circle. Oops. An open circle around 1/2, so between 0 and 1. And I'm going to shade everything that's greater than 1/2. So that's 1, 2, 3, everything to the right of 1/2. Then the other part is everything less than or equal to -3. So I'm going to go to -3. Oh, I missed something. Sorry, guys. You see my mistake? Hopefully you caught it before I did. But I made a mistake here. This is greater than or equal. This is just greater than. Somewhere along the way I forgot the or equal to part. Oops. So because there's the or equal to part, I want to actually make that a closed circle. Sorry about that mistake. All right, back to x is less than or equal to -3. Less than or equal to -3, I'm going to put a circle at -3. I'm going to make it a closed circle because of the or equal to part. And I'm going to shade everything less than -3. So everything like -4, -5, everything to the left of -3. And there's the graph of my solution. Number 2. 3 times absolute value of x minus 1 is less than 6. This one, before I split this into 2 different options, I want the absolute value to be by itself. This is kind of like problem 2 in our introduction. We had to get this absolute value of t plus 9 by itself first before we could split it into 2 options. So that's what I'm going to do on this problem. I'm going to get the absolute value by itself first by dividing both sides by 3 and just get that 3 out of the way so it's not something we have to worry about. This leaves me with the absolute value of x minus 1 is less than 6 divided by 3, which is 2. Now that I have the absolute value by itself, this is where I would want to split this into 2 different options. My positive option, which will look just like this equation, x minus 1 is less than 2, except without the absolute value sign. The other option will also have x minus 1. It's just going to have the sign flip around, and the 2 becomes -2. All right, I want to solve each of these. I'm going to solve this inequality by adding 1 to each side of the inequality symbol to get x by itself. I get x is less than 3. There's part of my answer. So all numbers less than 3 are going to be part of my solution. Same thing over here. If I add 1 to each side, plus 1, I get x is greater than -1. There's my two parts of the solution. I'm going to graph these. I want to make sure my graph goes from -1 to 3. So I think I'll start, if I start at -2, that'll work. -2, -1, 0, 1, 2, 3, 4. Awesome. All right, graphing these. I'm going to start with an open circle at 3, and I'm going to be shading everything less than 3 to the left. But wait a minute. If I do an open circle at -1 and shade everything greater than -1, this is one of those situations where I'm shading everything in between those two numbers. So I'm going to have those meet up in the middle here. And there's my solution. All right, this is the last of the video lessons for this unit. So from here, you should be fairly prepared for your test, which depending on if you have an A day or a B day will be on Thursday or Friday. Please make sure that you have all of these assignments finished. Your next classwork you can get from me. Thank you very much.